on here because if you can do goals 1 and 2, then this falls into place pretty simply, okay? Because what we do with this, you have to use goals 1 and 2, okay? Adding and subtracting is really pretty simple. When you add and subtract, the roots must be the same. So you can add things that are square roots with square roots. You can add things that are cube roots with cube roots. The roots have to be exactly the same. You can't add something that's a square root with something that's a cube root, at least yet. You'll learn to do that later. Also, for lack of a better word, the stuff under the radical has to be the same. Okay, so I can add a root 5 with a root 5, but I can't add a root 3 with a root 75. So we're going to talk about how we're going to make that the same if we can. Okay. Then once those things are the same, once your roots are the same, and once that stuff under the radical is the same, then you can add and subtract. And you simply add and subtract by putting together, combining the coefficients. The radical parts remain the same when you add and subtract. Okay, so 8 square root 5 plus 9 square root 5, 17 square root 5. The roots are the same, the radicals are the same, so all I'm doing is adding the two coefficients together. 8 plus the 9, 5 stays the same. When my radical parts are not the same, so that's 75 and 3 on this next question, you want to try to make it the same if you can. It's not always possible, so don't force it if it's not going to work. So 75, I'm going to break the 25 times 3. My 6 square root 3, there's a delay here because I've already written that. I could tell there was one coming. I'm going to just turn that off and turn it back on. Maybe it'll pop up. No, it's still not coming. So that means it's probably going to shut off. Let me do this again. There we go. Okay, so my 6 square root 3 is in its simplest form already, so I can't do anything to it. My 75 gets broken to 25 times 3. The square root of 25 is 5 times 3 on the outside gives me minus 15 square root 3. And then I take 15, or 6 minus 15, and I get negative 9 square root 3. So you break it down and simplify it just like you did today on your assessment. Okay? Negative 7 square root 20 plus 5 square root 45 plus 4 square root 80, all different. I'm going to take 20 and make it 4 times 5. 45, I can go 9 times 5. And then use that 5 as a big hint to get your 80 is 16 times 5. So then I have, on the first term, the square root of 4 is 2, times my 7 is negative 14 square root 5. The square root of 9 is 3, times my 5 is 15 square root 5. And then the square root of 16 is 4, times my 4 is 16 square root 5. So now I've made all my roots the same, or the roots were the same, they were all square roots. All the stuff under the radical is now the same. So negative 14 plus 15, 1 plus 16, 17 square root 5. As I started saying earlier, sometimes you can't get them to be the same, so don't force it. It's likely that some questions are not going to be the same. So like this next one, 24 is going to go to 4 times 6. And 27 is going to go to 9 times 3. So don't go and change 20, oh sorry, that fell over there. Don't go and change 24 to 8 times 3 to make it match the 3 because it doesn't work because 8's not a root. So this one's not going to end up the same. I'm going to have my square root of 4 is 2 times my 7 is 14 square root 6. And then my square root of 9 is 3 times my 3 is 9 square root 3. So your answer is that. You can't go any further than that expression. So you cannot make the radicals exactly like. You do have it in its simplest form, but we can't go any simpler than that. Okay? And then, of course, the same would be true of working with cubes or fourth roots or fifth roots. When you're working with the roots, you have to make the stuff under the radical the same. 16 is not a perfect cube, but it will break to 8 times 2. 8 is a perfect cube. 128 is not a perfect cube, but it will go to 64 times 2. Again, you can use your charts to do that. I'll let you use your charts for the all assessments. Okay. So the cube root of 8 is 2. The cube root of 2 I don't know. The cube root of 64 is 4. And the cube root of 2 I don't know. And now I can add them because they're both the same root and the same stuff under the radical. So 2 cube root 2 and 4 cube root 2, 6 cube root 2 for my final answer. And then the same one with fourth roots. 48 is not a perfect fourth root, but it will go to 16 times 3. 243 is not a perfect fourth root, but it will go to, what will it go to? 81 times 3? 81, yeah. So I've got the fourth root of 16 is 2. Times my 5 is 10. The fourth root of 81 is 3. Times my 2 is 6. Oops. And now I can add or subtract. 10 fourth root 3 minus 6 fourth root 3 is 4 fourth root 3. Anytime you're working with an nth root, not a square root, be extra careful, especially on a question like this, because you do this. This would be a common mistake. You got it to 16 times 3. You see 16 and you automatically think 4 because you're thinking square root. So instead of making this a 10, you make it a 20. Same here. You think you've broken it down, then you go square root of 81 is 9 times 2 is 18. Keep in mind when you're working with another root what you're working with. Okay, so kind of take a step back and slow down a second on any of the roots. Okay, that's important. So again, when I break this down, I'm not breaking it to square roots, I'm going fourth roots. So fourth root of 16 is 2 times my 5. So just, pause for a second and make sure you're thinking the other root and not square roots. Okay? Adding and subtracting gets no more difficult than that. It's important that you know that, again, the roots have to be the same, at least at this point. You'll learn to add a square root and a third root another time. And then the stuff under the roots have to be the same to add. And it's possible that you can't always get that to happen. Okay? But adding and subtracting is no more difficult than that. Okay? So I'm going to move to multiplication. To multiply radicals, again, the roots must be the same, at least right now. You'll learn to change those to make them the same eventually. Okay? And when you multiply radicals, I personally think it's easier to multiply first and then do the simplifying. Okay? You could simplify first on some questions, but if you do that, what you might have to do is simplify, multiply, and then simplify again. Where if you do the multiplication first, you only have to simplify one time. Okay? So I'm just going to suggest that you do the multiplication first. Okay? Once you multiply, then the questions look exactly like the assessment today. Okay, so that's why it kind of builds. That's why goals 10-1 and 10-2 are so important. So multiply first. 6 times 3 is 18. Once you multiply, then it turns into our assessment today. Simplify that. I'm going to make that 9 times 2. So I get 3 square root 2. Five square root 3 times 8 square root 21 gives me 40 square root 63. The 5 times the 8 on the outside, the 3 times the 21 on the inside. 63 is then going to simplify to 9 times 7. So I have the square root of 9 is 3, times my 40 is 120 square root 7. Six times 5 times 2 is 60. 60 is not a perfect square, but breaks to 4 times 15 to give me 2 square root 15. Seven square root x to the third y to the third x squared y to the third times 3 square root xy is 21 square root x to the third y to the fourth. No coefficient inside, so we only have to square root our variables. We're working with square roots, so 2 goes into 3 one time with 1 left over. And 2 goes into 4 twice with none left over. So again, if you did what we could, if you can do what we did today, the multiplying should fall into place real simply also. So let's multiply on the outside. Negative x squared y. And on the inside, x to the 6th, y to the 6th. I'm going to do this in a 2-step. 2 goes into 6 evenly, 3 times, none left over. For my y to the 6th, 2 goes into 6 evenly, 3 times, none left over. Leaving me negative x to the 5th, y to the 4th. When I put my variables together, remember that I'm adding powers. 2 plus 3 on my x's, 1 plus 3 on my y's.